Um, Let me know if you can't hear me at any point. I'll try and speak into the mic when I can. So like Toby said, this year DS2 is myself, Adam Holloway, and Yaniv Peer, who unfortunately can't be here today. Yaniv's practice exploration architecture, which is composed of a network of architects, artists, scientists, engineers, and other interesting people. And our interests in this unit are in biomimetic principles, computational design, future manufacturing technologies, and transdisciplinary design research. We are a unit about essentially finding solutions in search of problems. And I'll present briefly some projects here that myself and Yaniv have worked on together and separately, and also some work from the practice he's a part of. And then I will present the ethos of the unit, so what we're about and what our agenda is, and our working methodology, as well as some aspirational work that we hope to get out of the students in this unit. And then at the end I'll talk briefly about the unit trip, which is still in progress. Okay, so I'm an architect and a computational designer working out of London and in London, and I have my own practice in consultancy where I specialize in unusual small projects driven by design research in new digital tools, manufacturing processes, and architectural geometry. For the last 4 years, I've also been teaching at a number of London schools of architecture. I taught at London Met in the diploma unit concerned with rapidly deployable housing and infrastructure, and we looked at it from the perspective of new technologies and new digital design techniques. So here's an idea for a 3D printed rapidly deployable housing project that is primarily driven by gravity instead of using a lot of pumps and electronics, and things that pop up can be transported to site easily. We built a prototype for a house in Colombia for the for the Solar Decathlon run by the U.S. Department of Energy. I also run a module at Westminster University called Digital Craft, which is focused on introducing the students to new tools, digital tools and techniques in a cyclical process of digital design and making, so the students have engagement with new digital tools, and then they manufacture prototypes so they can realize more complex geometries and forms of expression than they would otherwise. I also teach at the AA in support of Diploma 16. I do some small workshops in new digital design and manufacturing techniques there with robots at Hook Park, sometimes various other things. I first met Yaniv about 8 years ago when I worked at Future Systems. We both worked at Future Systems, and I worked on this project for DuPont Corium called Supersurfaces Pavilion. And this project was interesting because it was an attempt to create a parametric design tool that could be fed into a system of reconfigurable jigs, whereby we could make this quite complex reactive screen system with a minimal amount of molds. So we created this reconfigurable mold that you could twist and change according to measurements taken off of the parametric model. And so since then I've worked on and off with Yaniv on a number of projects, and recently I worked with him at Exploration designing an exhibition for Exploration's work in the field of biomimetics and architectural design. We 3D printed a set of tables for the exhibition that you can see here. The tops of these tables were 1 millimeter thick, but we took inspiration from the giant Amazonian water lily, which has this unique venation pattern that provides it with an incredible amount of structural stiffness just through these ribs and this pattern. And we developed a similar system based on soft kill optimization, structural optimization techniques in digital modeling to create a set of tables for an arbitrary set of shapes that could be very thin at the top but still stiff enough to hold up models and other kinds of parts of the exhibition. and we 3D printed it in one with the help from an artist in Germany who since developed. He set up a company called The Big Rep, which he's since lost, unfortunately, but we worked with him in the early stages when he was setting up his company to 3D print these tables. Exploration, as I mentioned, is very interested in biomimetics and extracting design principles from nature, solutions in nature for the problems of today and tomorrow. They're most well known for the Sahara Forest Project, which is essentially a form of terraforming. They plan to use this greenhouse technology system to create an excess of nutrients to go back into the Sahara soil to create eventually arable land. But it has a cyclical connection with a number of other infrastructure components, providing solar power and food production for the local area. And there are a few prototype projects now in construction in Qatar and a few other Arab states where they're testing the system out. So exploration is very interested in cycles of turning waste products into useful products. So this is another somewhat famous one by Michael, where he looked at turning cardboard into caviar through a complex system of various stages whereby you produce food and other products. And that has since turned into some designs for a closed-loop restaurant in London and a textile factory that is aiming to be zero waste, which I worked on for a certain amount of time at Exploration as well. It's still in the development stages, but in this project they're also looking at other inspiration from nature for the structural systems for creating low material usage in structures and also low energy usage in ventilation systems within the building. So Exploration has a transdisciplinary approach to design, working with many different disciplines to implement innovation and inspiration from nature into the practical purpose of solving global and local problems. So that segues into what this unit agenda is about this year. And I've called it the Age of Entanglement, inspired by an essay by Neri Oxman, which I'll come on to later. But the connection essentially is that entanglement occurs in quantum physics when the interactions between particles are so complex that they cannot be described independently, but must instead be described in terms of the system as a whole. And as such, it's an apt metaphor for the state of creative disciplines and problem solving in the Anthropocene, where the issues affecting the built environment today are complex and multifaceted, from air pollution to rising sea levels, natural disasters, many questions about how we grow and eat our food, deal with our waste, find and distribute energy, all the while building for an ever-increasing global population. And governments are now acknowledging that future resilience in the built environment can provide multiple concurrent benefits to cities and their inhabitants, offering opportunities to respond in ways that help mitigate and adapt to challenges whilst promoting human health and well-being in ways that inspire as well as elevate. Responding to these challenges will require a new generation of designers, engineers, and scientists to think about infrastructure, food, waste, energy demographics, and population growth and economics in an integrated way, which will lead to new and radical solutions which promote reconciliation between humans and their environment. In 2007, John Maeda drew a diagram to describe the 4 creative hats he has worn during his career as an executive, a designer, and a technologist. The diagram divides a rectangular plot into 4 quadrants, each one devoted to a unique way of reading and acting upon the world: science, engineering, design, and art. Maeda assigned a mission to each plot: to science, exploration; to engineering, invention; to design, communication; and to art, expression. He conceptualized 4 discrete embodiments of creativity and innovation, which, like the 4 humors, each is regarded in its own substance, with its own content and its own countenance. Roughly speaking, if you're a citizen in one, then you're a tourist in another. Neri Oxman of MIT Mediated Matter Lab develops this map further when she proposes a more holistic and cyclical relationship between the 4 disciplines of creative exploration. She posits that operating in one domain can create a kind of creative energy which enables easy transition into another. Much like the metabolic Krebs cycle, which describes chemical reactions in biological metabolism. In this cycle, nutrients are oxidized to produce chemical energy, which in the body forms a kind of molecular currency. Crudely expressed, then, good metabolism will make you constantly rich, and by the same token can intellectual digestion, the kind that demands you shift views and perspectives, make you constantly intellectually rich. Oxman's mapping reimagines Midas matrix as a circle. As you move from one discipline to another, you generate and spend currency in the form of intellectual energy. The role of science is to explain and predict the world around us. It tests, analyzes, and documents to find patterns that conform to current modes of thinking. Thus it converts information into knowledge, whereas the role of engineering is to apply scientific knowledge to develop solutions for empirical problems. And it takes the models from science and tries to find a use for them. Through prototyping and large-scale applications, it converts knowledge into utility. The role of design is to make these solutions tangible in a way that maximizes function and augments human experience. It imparts technology to culture, society, and economy, and turns utility into behavior. The role of art, then, is to question human behavior and make us aware of the world around us. It converts behavior into new perceptions of information, representing the data that initiated the cycle in science. And at this Cinderella moment, when the hands of the cycle strike midnight, new perception inspires new scientific exploration. The DS2 is interested in pushing the limits of this schematic for transdisciplinary and creative exploration. Oxman's map provides us with a tool for navigation so that we can plot the development of an idea or an invention or design in many ways, starting from any of these disciplines. The diagram can be read as a compass. It goes north to south and east to west. The north to south axis leading from information produced by science and art into the hemisphere of perception to utility produced by design and engineering into the hemisphere of production. The farther north, the more theoretical or philosophical the regime, the farther south, the more applied or economic the regime. The north marks the climax of human exploration into the unknown, while the south marks the products and outcomes associated with new creative solutions and deployments based on exploration.